We're going to spend the rest of the time on this unit talking about a concept of thermodynamics called enthalpy. And this is a part of thermodynamics that can get a little complicated. In fact, your textbook in one of the sections in this chapter goes into how enthalpy is derived from qualities of like work and energy and all of those things. And it gets a little complicated. I'm not going to require knowing how to do those derivations. If you want to read through it in your textbook, I recommend it, but I'm not going to test you on how we come about enthalpy. But for right now, we're going to kind of keep it simple. And we're just going to say that we're going to view enthalpy as a measure of the heat of a reaction. And most of the time, like 99% of the time when we talk about enthalpy, we're talking about the change in enthalpy between reactants and products. And we're going to view this, and this isn't always true, but for our class and for what we will do this semester and next semester, this is going to be true that the change in enthalpy is equal to the heat of the reaction. And we kind of look at this change of enthalpy in two different ways. We'll look at it as either endothermic or exothermic. And in most chemical reactions, heat is either absorbed or released. And that's where we get these terms endothermic and exothermic. If you think about those prefixes, endo means like within, and so that's where heat is absorbed. And exo meaning like outside of, that's where heat is released. So just to kind of clearly define those terms, endothermic means that heat is absorbed. And to kind of put it into something that we understand, like a sensory feeling, this is when something like feels cold. So some of you may have experienced this in some of the reactions you've done in general chemistry. You dissolved something in water and then suddenly got very, very cold. That's an endothermic process. It's absorbing heat from the outside surroundings, and it feels cold. Or like when you put an ice cube on your in your hands, the ice is absorbing heat from your hands, and therefore it feels cold. It's reducing the temperature around your skin. Exothermic is the opposite, where heat is released. And this is when something feels hot. So you probably have experienced some of these very things in your lifetime. Like for example, like an instant cold pack. The chemicals in there are probably what probably is in there is ammonium nitrate. And when you crush that bag up, it breaks the container of ammonium nitrate and mixes it with water inside. And so it essentially dissolves that ammonium nitrate. And it adds heat as a reactant. It absorbs heat from the outside surroundings, and so therefore it feels cold. And if we were to put a positive or negative sign to this change in enthalpy, we would say that the change in enthalpy is positive, where the energy of the products is greater than the energy of the reactants. Let me put this into something like that we can look at it in a picture. I'm going to draw something called a reaction coordinate or a reaction diagram. And this is something that we'll go a lot more deeper into Chem 102. But on the y-axis, we'll put energy. we can look at this as enthalpy as well. And then the reaction progress goes on the x-axis. So we typically draw it so that reactants start here, and the products in an endothermic reaction, the energy of the products ends up higher. So the enthalpy of the product is greater than the enthalpy of the reactant. And so delta H ends up being a positive value. Now, on the flip side of this, let's look at what an example of an exothermic reaction. So you did this in lab, or actually you'll be doing this very soon in lab if you haven't already. We're going to do a neutralization reaction, react an acid with a base to produce a salt and water. And this process also releases heat. So here, heat is a product of the reaction. This is an exothermic product because heat is being released. And in this case, the sign of delta H will be negative. The energy of the products is less than the energy of the reactants. And if we draw a reaction coordinate for this, again, same axes, we're going to look at energy as enthalpy here, and the reaction progress on the x-axis. Our reactants have a higher energy than the products. So the enthalpy of the products are less than the enthalpy of the reactants, and delta H is negative. So it's important to know these two terms, exothermic, endothermic, because we're going to go into them. We're going to use them quite a bit. And so you need to associate that relationship of either energy being absorbed for an endothermic process or energy being released or heat being released in an exothermic process.